yesterday we discussed about local attraction. Local attraction means it is the magnetic needle will not show or align exactly in north and south directions. So therefore, there will be some horizontal angular difference between the true meridian and the magnetic meridian. So this angle subtended by the true meridian and the magnetic meridian, we call it as local declination. And local attraction means due to the presence of some magnetic substances in the field, the magnetic needle will not align itself in north and south direction, and it is going to deviate. This deviation is due to the magnetic substance that is present in the vicinity where you are carrying out the survey work. And how to detect this local attraction is, if you have carried out a traverse, check the forward bearing difference between forward bearing and back bearing any particular line. If it is exactly 180 degrees, then that particular stations are not affected by local attraction. If the difference is other than 180, if it is 179 or 181 degrees, then it indicates both the stations or any one of the stations is affected by local attraction. So this is how you can detect local attraction. How to eliminate? We discussed two methods. One is that is both the methods are going to solve the problem after detecting the this one, and after solving the problem how to clear or how to eliminate this local attraction. So now I will take up the problem. The following bearings were observed while traversing with a compass. Mention which stations are affected by local attraction and determine the corrected bearings. So here line is given. See, line, forward bearing and back bearing of the lines, they are given to you. So for the line AB, forward bearing is going to be 45 degree 45 minutes. 45 degree 45 minutes. Back bearing is given to be 226 degree 10 minutes. For the line BC, forward bearing is given to be 96 degree 55 minutes. And back bearing is given to be 277 degree 5 minutes. For the line CD, forward bearing is given to be 29 degree 55 minutes. And back bearing is given to be 209 degree 10 minutes. And for the line DE, so it is a open traverse, you cannot apply the second method here. 324 degree 48 minutes, and back bearing is going to be 144 degree 48 minutes. So now you need to determine the corrected bearings. See, first step is look at the difference between forward bearing and back bearing of the line. If you observe last two figures, it will be clear to you. 45, 10, you cannot get exactly 180 degree difference. 55, 5, you cannot get. Similarly, 55, 10, you cannot get. 48, 48 is there, check it. 324 degree 48 minutes minus 144 degree 48 minutes. This gives you exactly 180 degree difference. So now it means to say that the stations D and E are free from local attraction. These are not affected by the local attraction. Whatever bearings that we have measured from these stations are the correct bearings. See, the traverse may be like this: A, B, C, A, B, C, D, and E. See, whatever readings that you are taken from D and E, these are correct bearings. Right. So in the first method, we are starting our work of correcting the bearings from the bearings what are measured from these stations. Which are the bearings measured from E? That is, back bearing of DE is measured. That is 144 degree 48 minutes. It is a correct bearing. Similarly, from D, you have measured forward bearing of line DE and back bearing of line ABC. Okay. One line I have taken extra. C2. See, from station D, we have measured the forward bearing of DE and back bearing of DC. These three bearings are correct bearings. There is no correction for this, and this reading. Right. So, we will start from this bearing. We will simply write correct forward bearing of line, correct back bearing of D is equal to 144 degree 48 minutes. It is a correct bearing, no correction. Next is correct forward bearing. We are coming from here and we are entering into the problem. Correct forward bearing of line DE is equal to 324 degree 48 minutes. These two are correct. Similarly, correct from D, you have also measured the back bearing of line CD, that is this reading. So, that is also correct. Correct back bearing of DE is equal to 209 degree 10 minutes. See, all these stations may be affected by local attraction. We do not know what is the amount of correction to be made. So, these three readings are correct. See, knowing the correct back bearing of DE, we can determine correct forward bearing of DE. So, how do you determine correct forward bearing of DE? Add or subtract 180 degree from its back bearing, you are going to get this particular angle. So, 209 degree 10 minutes minus 180 degree. You are going to get 180 minus, if you do, you are going to get 29 degree 10 minutes. This is the correct bearing. But observed bearing is there. But observed bearing is observed forward bearing of BE is equal to, see, come here, it is 29 degree, 55 minutes. 29 degree, 55 minutes. Determine the error in observation. So, error in observation is nothing but equal to observed bearing minus correct bearing. See, observed bearing is 29 degree 55 minutes minus 29 degree 10 minutes. So, error is nothing but equal to 45 minutes. Positive or negative? It is positive error. Therefore, apply correction. How much amount correction I should do? Correction is equal to minus 45 minutes. So, for all the readings observed from this particular station, that is C, you need to apply a correction of minus 45 minutes. Which is the other bearing measured from station C? One is forward bearing of CD, Next is back bearing of BC. So, correct back bearing back bearing you can find. Correct back bearing of BC is equal to observed bearing, that is 277 degree 5 minutes minus 45 minutes. So it will be equal to 276 degree 25 minutes. 25 minutes means you bring 1 degree this side, 60 minutes it will become. 60 plus 5 minutes is 65. Out of 65, if 45 is deducted, then you are going to get 20 minutes. 20 minutes. 276 degree, 20 minutes is the correct back bearing of BC. So once you know correct back bearing of BC, you can find correct fore bearing of BC. Correct fore bearing of BC equals to 276 degree 20 minutes minus 180 degree. Take 180 degree difference. Since it is greater than 180, 180 should be deducted. So you are going to get how much degrees? One minute. Okay, we start from the starting point. Correct back bearing of DE, it is correct. Correct fore bearing of DE, this is also correct. Correct back bearing of DE 9 degree 10 minutes, 29 degree 10 minutes. But observed bearing is 29 degree 55 minutes. Therefore, error in observation 29 degree 55 minutes. Okay. It is 45 minutes. Correct fore bearing of BC is equal to 276 minus 180. So it will be 96 degree 20 minutes. 96 degree 20 minutes. See, but observed fore bearing of BC is equal to, see, observed fore bearing of BC, come to here, BC fore bearing is 96 degree 55 minutes, 96 degree 55 minutes. So once again, you determine the error in observation. So error is nothing but equal to observed bearing, that is 96 degree 55 minutes minus correct bearing 96 degree 20 minutes. So you are going to get an error of 35 minutes. 35 minutes positive. So for all the readings measured from station B, apply a correction of minus 35 minutes. So, which are the readings measured from station B? Already for BC we have applied the correction. One more reading observed from station B is back bearing of AB. So, correct back bearing of AB. Correct back bearing of AB is equal to observed back bearing 226 degree 10 minutes minus 35 minutes. So you are going to get this as 226 degree 10, 70, 35, 35 minutes. 1 degree you bring it to the right hand side, it will be 70 minutes. Out of 70, remove 35, 35 minutes will be remain, and 225 degree 30 minutes. is the correct. Determine once you know correct back bearing of any line, correct forward bearing of AB can be determined by taking 180 degree difference from this. So 225 degree 35 minutes minus 180 degree. So you are going to get this as 225 minus 180. It will be 45 degree 35 minutes. 45 degree 35 minutes. See, in the first method, we can apply the correction like this. So now you need to comment on the results. Stations C, B, and A are affected by local attraction. Stations and stations C, D, and E are free from local attraction. So this is how you need to solve the problem from first method. Okay, we can do this problem in the form of a table, right? So we can also solve the problem in the form of table. You may feel still easier because table in the table directly we can apply the correction, right? I will do it in the form of table, alternate method. So in the first column, take line, then second column, observed bearing, third column, correction to be applied, correction. Then in the next column, you can take correction, corrected bearing, then have one more column for remarks. So in this method, I think you may feel it very easy for the line AB. Reading is, compass is kept on A and reading is taken sighting towards B. AB means forward way, 45 degree, 45 minutes. Right. Once again, I will take the traverse A to B, B to C, C to D, D to E. Right. Keeping the compass here, you have kept the ranging rod at B and you have taken a reading on B. That reading is 45 degrees, 45 minutes. Then you are shifting the instrument to B. So, and you are taking the back bearing of AB. Back bearing of AB is nothing but forward bearing of BA, I can call. So here, keeping the instrument at B, sighted towards A, and back bearing is taken 226 degree, 10 minutes. Right. Then from B, you have kept the ranging rod at C, and you have taken one more reading BC fourth bearing of BC, 96 degree, 55 minutes. 96 degree, 55 minutes. Then you have shifted your compass over D, over C, and you have taken the back bearing of CB. So, compass is at C, ranging rod is at B, or sighted to B, and the fourth back bearing of BC is taken 277 degree, 5 minutes. Right. Then from C to D, you have taken fourth bearing of line CD, 29 degree, 55 minutes. Then the instrument is shifted to D and back bearing is taken, that is DC. DC means 209 degree, 10 minutes. 209 degree, 10 minutes. Then one fourth bearing of E is taken, DE. DE. DE, it is 324 degrees, 48 minutes. Then the instrument is shifted to point E and back bearing of ED is taken. So you can write ED. ED is 144 degree, 48 minutes. 144 degree, 48 minutes. See, here in this column, the first letter indicates where the compass was. Second line indicates towards which point sighting is done and reading is taken. So, from A, you have taken only one reading, AD, AB. From B, you have taken two readings, back bearing of AB and fourth bearing of BC. Similarly, from C, two readings, from D, two readings, from E, one reading. And observing here, 144 degree, 48 minutes. So, both the stations D and E are free from local attraction. So, enter the amount of correction from readings observed from E, 0. Readings observed from D, again 0, because they bear exactly 180 degree difference. Therefore, 0 correction. So, 3 of the corrected readings I can write it directly without any calculation. 209 degree, 10 minutes. 3, 24 degree, 48 minutes. 144 degree, 48 minutes. These 3 are already correct. There is no correction. The amount of correction to be applied is 0. So I have translated all the readings as it is. Right. Now you determine correct back bearing. Knowing the correct back bearing of DC, you can correct this CD. Take 180 degree difference. You are going to get the corrected bearing of this. 209 degree, 10 minutes, minus how much? Minus 180 degree. You will get correct bearing as 29 degree, 10 minutes. What is the amount of correction? See, compare these two. What is the error? It is 45 minutes. Positive or negative? I should deduct from this to get correct reading. So, minus 45 minutes. So, for all the observations made from C, you need to correct by 45. One more reading is observed from C, that is CP. So, correction to be applied at C is minus 45. So, if you deduct from this minus 45, you are going to get 276 degree, 65 minus 45, 20 minutes. correct reading. See, once you know the correct and varying, take 180-degree difference to get the back varying of BC. So 276 degree 20 minutes minus 180. So you are going to get 96 degree 20 minutes. 96 degree 20 minutes. Compare this. What is the amount of correction? This is more than this. By how much? I should deduct from this. That is 55 minus 20 minus 35 minutes should be deducted. So correction is minus 35 for all the readings observed from B. So from B, one more reading is taken, minus 35 minutes, right? So if you apply correction to this, you are going to get the correct rate varying, 226 degree 10 minutes minus 35. So if you bring 1 degree to this side, it will be 70. Therefore, 35 minutes is going to remain, and 225 degree, 225 degree, 35 minutes. So, now knowing the correct back varying of BA, you can find, take 180 degree difference. So, 225 degree, 35 minutes minus 180 degree. So, you are going to get 45 degree, 35 minutes. So, what is the amount of correction here? 45 degree, this has to be minus 10 minutes. So, in the form of table also you can solve the problem in an easy way. But to do this, you need to practice. You need to practice some 3-4 problems, and then only you will come to know all these steps. Just by reading the notes, you cannot learn this. You need to practice, and then you need to work out the problem. So here, the remarks column, you can say, stations A, B and C, A, B, C are affected by local attraction. So, whichever method is easy for you, that you can practice.